So this is going to be broken up into almost three parts. First is showing you an extremely simple example of what to do with the stack in coding it. Next, I'm going to have an exercise for you to all do. We'll hit pause, get the exercise done, and then I'll show you answers, and that'll be part 3 is showing the answers. But I first got to start off with, frankly, that, hey, what is and how do we use a stack? Now, here's a couple of different things here. You can create different types of stack. You can use the concrete type, which is the integers, the floats, the doubles, etc., the ones that we're used to, the basic type, and as you can see on line number 1 that's being highlighted. But you can also create custom object holding stacks. And you'll see that with the highlighted set right now being called students. So think of it as me creating a student object that had a name, first name, last name, and a score, something like that. That's the beautiful part of this, is that you can put any data type that you want into the stack as long as you've done a good job of making sure that some things are taken care of with your custom object, which again, I'm still going over a little bit later. But the beauty part is it still works. And we still have the same functionality. So notice here's the student that I was talking about, the first name, last name, and the score. We're going to go ahead and notice I have a push functionality for 3 of them. Now, we have Demo 2, and then CMSC 341, which is a class. Now notice, by the way, the difference between 2 out of 3 of them. The big difference for the last one, which is the CMSC 341, is that it is a dynamically created stack, and we've talked about that before. So we can go ahead and delete things and all that good stuff. It's a little bit more powerful. But with more power comes greater responsibility, so we have to worry about certain memory management things and items like that. So you'll notice instead of using the dot notation, we're using the arrow notation. But notice it's still overall the same setup. You're still using the name of the instance, arrow, the name of the function you want to do, and then what you're throwing in there. The other parts I'm trying to show you is how to access some of the other features with it. Notice it's super dumb easy. And remember, again, we don't have a lot of functionality when it comes to a stack anyway. And that's what I'm doing through most of this, is trying to basically set things up for you so that, frankly, hey, it's not super hard to understand the code and figure out the code and add to your own code. So here's what I would like you to do for now. We'll go over an answer here in a second. So you're going to draw what these 3 stacks would look like before they had their elements popped off. So just before their elements were popped off. And then I want you to find the calls to top in the code above. And in the comments of the line, why was the greater than symbol, the overloaded cout and the overloaded equal, how were they set up and used in this overall function, or setup of code, I should say. So talk about that, follow the 2 questions that I have right here, and we'll go over answers here in a bit. So again, please hit pause, do the work I'm giving you, please, instead of just going right to the answer, and then we'll go over an answer here in a little bit. So here's what the stacks look like before they start popping things off. This is going to be a very visual class. I'm a visual learner, although I heard that's not a thing anymore, but I still believe it. So I'm going to draw things out for you as best as I can, because a lot of you probably understand pictures better than text and words. So you'll notice that the integer dem, which was named demo, really didn't change too much from what you expected. It had a number in there called 17, and that was at index 0 before we popped it off. Then in Demo 2, which was a little bit more interesting because we had a student, which was Professor Lupoli, and then 99, and then we popped that off eventually. But then CMSC 341, you'll notice that I have an arrow going to it because that really is what's happening. This is using a dynamic array that's using pointers to set things up and stuff like that. So that's already set up. And then we actually had two things that were in there. I can't remember what the first one is because my handwriting's terrible. It looks like we had JoJo Lee for the next one, and boy, their score was terrible. But notice it's acting exactly like a normal stack that we've had before, so there's no changes when it comes to that. And again, I wanted to make sure that you understand how things are working out visually, because they are different in each of the elements of these stack. So in number 2, where was the equal, the overloaded equal, and the overloaded cout used in the code? Now remember, if we're doing some type of overloading, we're doing it because it doesn't work with the basic data types of ints, strings, that type of stuff. We're using it because we have a custom data type and we want it to display, well, some information, and the regular cout won't cut it. So we have to overload the cout, or we have to overload the equal sign because, again, for the equal sign, remember it does simple integer or character or conversion, or I shouldn't say conversion, but setting of a value. But how do I do that with a custom object? So that's where the equal comes into play. And we had that really basically in these two lines, is that this cout is using the overloaded cout for a student. So notice I'm getting into now slowly into functions that you need to have with your custom objects for the STLs to work. So you definitely have an overloaded cout, and you definitely have an overloaded equal. So heads up on that. So, but that's how this is going to work out, is that there were some assumptions that there's some code behind the scenes that frankly needed to be done with it. And again, we'll talk more about that. But at least wanted to go over those two items with you. So how do we pass our STL data structure to other functions? Now there is a trick, so we're going to be really careful about this. So pretend I am passing my examples here to a peek function. So number one, what's being highlighted right now, notice that would be your code in order for it to be passed into a function. But on the calling side, it's also a little different too. And you'll see them being already highlighted in green. If you're using a non-dynamically set up data structure, STL data structure, notice you have to use the ampersand because, again, you want to give it the address to the rest of the material. Notice for a change in the 341 one, which was already the dynamic one, it's already expecting the address because that's the pointer to the address and to the rest of the material in that particular data structure. So you got to be careful on exactly what we have set up here. This also gets into the point of some more overloaded options you may need, because if you're going to try to pull information from it, return information from that data structure of the STL data structure, you're going to need some other items that are being highlighted right now that are probably an overload. That's the less than sign, not equal to. For students, what are two students that are not equal to one another? Are we just worried about first name, last name, or are we worried about score? We have to decide with our custom data structures what all of those items really mean, because again, it's a custom data structure. Two students are not the same. They may have the same GPA, so what are we worried about? So these are some design things we have to worry about, and we're going to get more and more into that as well. So notice the code is not all that hard to manipulate with the STLs, but our designs, we have to really think much harder in our designs of our custom objects that work with the STLs.